Go now.
From the question, remove the parameter. Mass 5 kg, force 8 newton. We are looking for the coefficient of friction is unknown and gravity due to acceleration is 10. Then the formula is W equals to mass times gravity. And the answer is W equals to 50 kg. For finding the coefficient of friction, coefficient of friction equal to force over normal reaction. That will be 0.16.
Okay, that's great, and that's in line. Thank you. Now, W is R. W is the same thing as R. Normal reaction is the same thing as what? The weight. Which is R, which is the weight, right? Which is mass times what? Gravity. That's the weight of an object. So the mu, coefficient of static friction, is what? Force over normal reaction. That is 8 over what? 50, which is what? 0.16. Thank you. Next question. A 100 kg box is pushed along a road with a force of 500 Newton. If the box moves with a uniform velocity, the coefficient of friction between the box and the road is 0.5, B 0.4, C 1.0, D 0.8.
kg, and the force is 500 newtons, and the coefficient of friction is not given. So first, we have to use this formula: R equals to mg. So R is equals to mg. So the m is the 100 and the g is the gravity. That's 100. That is 100 times 10. That is 1000. So you get it. I got 1000 newtons. Sorry. Then mu, this is the formula for mu. Mu coefficient of friction is equal to F over R. So by the time you put your figures in places, then this is your answer: 1 over 2 plus 0.5.
A body of mass 10 kg rests on a rough inclined plane whose angle of tilt theta is variable. Theta is gradually increased until the body starts to slide down the plane at 30 degrees. The coefficient of limiting friction between the body and the plane is loud, very loud.
Okay. You're asking the coefficient of the limiting friction. So you don't need to calculate anything, just coefficient equals to tan 30. So tan 30 is 0.58. Very simple, something.
Next question. A force 100 Newton drags a mass 10 kg on a horizontal table with an acceleration of 0.2 meter per second square. If the acceleration due to gravity is 10 meter per second square, the coefficient of friction between the moving mass and the table is force 100 Newton drags a mass 10 kg on a horizontal table with an acceleration of 0.5 meter per second square. If the acceleration due to gravity is 10 meter per second square, the coefficient of friction between the moving mass and the table is 0.02, A, B 0.08, C 0.20, D 0.8. Meter per second square. G is what? 10, right? And what more? Force is what? 100 Newton. Okay? Your record tonight, mass is 10 kg A is 0.2 meter per second, G is 10 meter per second square. So coefficient of static friction is what we are asked to calculate. In that regard, the formula is F all over normal reaction. F is what? MA, R is what? Mg. So 10 times 0.2 all over 10 times 10. 10 times 0.2 is what? 2. 10 times 10, 100. 2 divided by 100 is what? 0.02. I love that. Don't forget, we were given force. In this case, we are given force 10 Newton, right? The force is pulling the object. But you know the object has resistance against the force, right? So to get the force, what you say is resultant force. The resultant what? Force will be this particular force applied force minus the weight of the body minus the force on the body. The force due to the body or the opposition to the movement. This is applied force, which is 10 Newton, right? This force is the mass ME. ME. Are you hearing me? 10 minus 10 times what? 0.2. 10 times 0.2 is what? Is equals to what? 2 Newton. Are you hearing me? Resultant force is what? 2 Newton, right?
No, sir.
Mu is equals to force all over R. So force is 2 all over what? R is what? Minus 2 is what? 8 Newton, right?
Yes, sir.
8 what?
Newtons.
Newton. So it will be 8 all over what? Normal reaction is mg, which is 10 times 10.
0.
8 all over
100.
is what?
0.08.
Coefficient of static friction between a 40 kg crate and a concrete surface is 0.25. Coefficient of static friction between a 40 kg crate and a concrete surface is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base, inclined at 45 degrees to the horizontal. Friction